Now we're going to move on to deriving the geometric sequence series formula. We are going to take our geometric sequences and then we're going to add them all up, and that is what a series is. Series in your brain should equal add numbers together. Sequence just means a set of numbers. It has a pattern usually. In this case, they're going to have a ratio that is similar. But a series where you add all the numbers together. So say I had a series and I need to add up the numbers 2 plus 6 plus 18 plus 54 plus 162. This is something I can easily just punch into my calculator, but I'm not going to do that. I'm going to use these 1, 2, 3, 4, 5 numbers and show you how to derive the series formula from these numbers. So this is what we're going to do. We're going to take the same concept as before. I'm going to rewrite the sequence. S of n is equal to a plus ar squared plus ar cubed plus ... plus ar n minus 1 all the way to n minus 1. See, all the way to n minus 1. We are going to derive this, which means we're not going to memorize this formula. We're going to come up with this formula so that we don't have to memorize it in the future. But you may memorize it anyway. Now, what I'm going to do is do some tricky math, and I'm going to multiply our sequence or series by r. So I'm going to multiply this whole thing by r, both sides, because what I do to one side, I have to do to the other side. So I'm going to get rsn on the left side is equal to, and I have to distribute here, so r times a is ar times r is ar squared, and then ar cubed plus all the way to ar n minus 1 plus arn. Now, why is arn minus 1 times r? I'm going to do it I'll do it in my scratch work right here. Scratch. I'll show you the very last term. arn minus 1 times r. We have the same base, so we can add the exponent. So n minus 1 plus 1 will just give us arn. Okay? So, I'm going to erase this now because I need more room. Also, this darker blue is our new equation. So I'm going to get rid of our scratch work here. But I'm going to do the same thing with, we need to multiply, our ratio is going to be 3 in this case. So 2 plus 6 plus 18 plus 54. I'm just copying down the problem because we're going to multiply everything by 3, both sides by 3. So we're going to get 3s on one side. 3 times 2 is 6. 3 times 6 is 18. 3 times 18 is 54. 3 times 54 is 162. And 162 times 3 is 486. I did not do that in my head. Now I'm going to get rid of this part because I distributed on your paper. You can just cross it out. Now what I'm going to do is I am going to subtract, big subtraction sign, both of these blue equations. This equation, take away this equation. Here's what I get. S minus rs sub n, s sub n minus rs sub n is equal to a minus 0 is a, ar minus ar, oh, that's 0, ar squared minus ar squared is 0, ar cubed minus ar cubed is 0, arn minus 1 minus arn minus 1 is 0, 0 minus ar is negative ar to the n. Oh, now I'm going to factor out the greatest common factor, which is s of n, 1 minus r. Now you wonder why we spend half a year factoring. I'm going to factor out the greatest common factor on this side, which is a, 1 minus r to the n. Now I can isolate, we're getting really close now. Now I can isolate s sub n by dividing both sides by 1 minus r. S sub n is equal to a 1 minus r to the n over 1 minus r. Just like in our problem. Let's do it with the numbers though. Let's bring down this guy a little bit more. Line up my equal signs. Okay. Let's subtract everything. S minus 3s is equal to 2 minus 0 is 2. 6 minus 6 is 0. 18 minus 18 is 0. 54 minus 54 is 0. 162 minus 162 is 0. 0 minus 486 is there. So now I'm going to factor out the greatest common factor. 1 minus 3 is left. And now I'm going to factor out a 2, which is my greatest common factor. And I get 1 minus 243. And here's what you don't notice. But 243 is equal to 3 to the 5th power. Which is convenient because notice 1, 2, 3, 4, 5 numbers we were adding up. Our n value was 5. 3 to the 5th power. 2 times 1 minus 3 to the 5th power. And scratch work. I'm going to divide both sides by 1 minus 3 to mirror this. And I'm going to get our summation is 2 times 1 minus 3 to the 5th over 1 minus 3. So I just did this 2 ways, one with numbers on the left side and one with just the variables on the right side. This is going to work for all your geometric series. And you're going to see this more and more often. This is the beginning of many conversations you're going to have with geometric series. And just know that R is your ratio, N is your number of numbers, and A is your starting number. So let's go over this in this problem. In this case, our R was 3 because we took any number, 6, and we divided it by the previous number and we got 3. So our R value is 3. There were 5 terms in our series. So this is where the N is 5. N is equal to 5, R is equal to 3, and A is our very first number in our sequence, 2. You plug it into this magic formula, and you end up getting your series. If you actually punch this into your calculator using your order of operations, and you add up 2 plus 6 plus 18 plus 54 plus 162, you will get the same answer. Hang on, because you're about to start part 2.